how we're recording. And so this, do you guys know what this is called? What's that graph called? And it even says slope field generator up there. Yes. It's a slope field, right? Do you remember making a bunch of these, those of you that had AB?
Do I ever?
So what this is, Aiden and Jack, this is just graphing a function by using its slopes at various points instead of using x's and y's. And you can see kind of the general shape of this. How would you guys describe the pattern of this slope field?
This is parabolic.
Parabolic.
Yeah.
Yeah, I agree. Exponential.
Wow, I really screwed up there. Like if it would have gone up on the other end, it would have.
Yeah, if it would have, yeah, sure. If it would have done one of these, then sure.
Yeah, exactly.
Doesn't quite do that. And you guys said what? Exponential seems pretty reasonable. So if we were to try to sketch in kind of your typical exponential curve, that's not quite steep enough. Something like that maybe. And I did my best to put in an equation that might represent a good solution curve. What do you think of that red graph? I thought exponential as well, right? E to the 0.7x is what I came up with, and it seems to fit pretty well. It's probably not perfect, but it's pretty close. So this is something we did in AB, right? The AB veterans, we did this in AB. And I wanted to introduce you guys to something that is a little different and a little more in tune with what we'll be doing at some point this year. So I'm changing the differential equation that's giving me the slope field. Now this looks a little different, doesn't it? Doesn't it look similar to what we just had up there? Doesn't it sort of look exponential? In fact, if I let this exponential go back on there, can you see how for a while it looks pretty good?
It's cubic.
Yeah, sure.
Not quite a cubic. It almost looks like one of those like 1/3 power functions. It's not quite like that. I mean, it's really close looking. I agree. It does represent that, sort of. But can you see how the exponential, the red graph, now that I've changed the differential equation, I've changed the slope field, for a little while it matches, but then after a while it doesn't match at all, right? It's way off. So this, of course, is not exponential. It's related for sure. It's something like this. As far as a solution curve goes, that would be the actual functions graph that would describe this pretty well. And I wanted to give you guys just a second to think about what kind of like real life scenario could be modeled by a graph like that.
A really cool slide.
A really cool slide, for sure. What else? Can you think of anything? I mean, somebody said earlier, I think Julia said, it looks like there's a horizontal asymptote. I agree. So it's almost like the growth, like this green graph does grow pretty steeply, but then as it gets higher and higher, the growth is capped, isn't it? It looks like there's a horizontal asymptote there at the top and another one at the bottom. So what kind of situations could you think of where something is growing, getting larger and larger, but it's limited? It's going to be capped. It can't just grow exponentially forever and go and go and go. It's going to be sort of capped off.
You can say like employees or like
Speed driving a car?
it's like employees in like the service industry. Like, you can only have so many people like in a kitchen or something.
Okay, so you can only fit so many people in the kitchen.
Your height.
Or like their
Your height? Yeah, sadly.
mine was more just
At some point we stop.
You
Yes.
could say like population because it'll grow exponentially until it hits like the cap of the environment is where the food is.
Sure. So I've heard a couple of really nice thoughts here. Nick said essentially there's only so many employees you could fit in a kitchen.
or like or adding more people would only help only so much. Like there would only
Yeah, after a while it almost would be a hindrance, right?
Yeah.
Yeah, for sure. And you're talking about the same kind of thing. Aiden said something about like population being limited, right?
Yeah, like eventually the environmental factors will limit the growth.
Environmental factors, I like it. So this curve is called a logistic. You don't have to write this down or anything. This is just a preview. This is called logistic growth or logistic growth curve. And what these two gentlemen came up with is a pretty decent description. It's It usually has to do with some kind of a population, has to do with the fact that population is limited. Have you ever heard people refer to bunny rabbits as like reproducing exponentially? And of course, it's figure of speech. It just means they reproduce very quickly. But quite literally, they can't. Because aren't there, to use your word, environmental factors that limit their growth? What might be some of the environmental factors that limit the growth of the bunny population?
Snakes.
Snakes.
Yeah.
Food.
Human.
People, yeah. Somebody hunting bunnies. Or how about even just like land size, right? Like if you just have a big old field, you might be able to fit like 1,000 bunnies in there, but you can't fit 10,000 because there won't be enough space or food or water. And there's snakes and there's birds, like, eagles and hawks will come get bunnies too, Kind of sad, but true. Dogs even. Oh, my dog tries so hard.
My car.
Yeah, cars, Jeeps cruising across this field or something, yeah. And so as the population of bunnies or whatever reaches kind of that steepest point, it starts to cap off, right? It's still growing, number of bunnies growing still, but then you get really close to what we call the carrying capacity. That's what this horizontal asymptote would represent. It's called the carrying capacity. It's how much the environment can handle. The growth rate really starts to taper and get flatter and flatter and flatter. And, this is where the model doesn't totally hold up because we can't have like infinite time, right? We can just see this pattern of like, whoa, we think. And what would you guys say? What's the carrying capacity for this particular scenario? 10. And maybe you already noticed this, but this number right here, 10, in that equation that I wrote up there, that's always going to represent the carrying capacity. These are all details you don't need to know until way later. I'm just kind of filling you in a little bit ahead of time. Okay? So this is the kind of thing we'll look at in AP Calculus. It's a continuation of AB. It's called BC now because it's sort of like Calculus 2. And that's kind of the long and short of it. Honestly, 60% of BC is AB. It's no more difficult. It's the same stuff. We just do 40% more things, topics, concepts, and things like that. That's all that BC is. Okay? That makes sense? Okay, it's all that. That's it. Okay, fantastic. Would you guys grab the 3x5 cards real quick on your table? And we are going to do just a brief get-to-know-you thing. And this is just me. It says find the absolute, max, and min. And so what it's basically asking for is what is the highest point and what is the lowest point? Another way to think of that would be the highest y and the lowest y. So the highest y and the lowest y. And you could do this a number of ways. You could just start, and you see you've got this interval over here, -1 to 3. You could just start plugging in a bunch of numbers on that interval, right? You could say, well, let's try 0. See what happens. Let's try a 1. Let's try a 2. The hard part is, you could certainly do that, but then aren't you going to pretty quickly realize that you can't test out all the possibilities? Because how many numbers are there between like -1 and 0?
A lot.
Yeah, you're never going to test them all. And so what we do is we find likely candidates, is the word I use. We're going to find realistic candidates, okay? And the realistic candidates are going to come from 2 categories. Veterans, you remember what are the 2 categories?
Critical points.
Critical
Critical
point?
numbers and endpoints.
Critical numbers and endpoints, or critical points and endpoints, right? So we're going to be looking for, these are our candidates. These are the only realistic possibilities. Candidates are endpoints and critical numbers or critical points. Okay, so the endpoints, painfully obvious, right? -1 and 3. That's your interval endpoints. So when I list out all my candidates, I'm just going to make a little table here with an X and a Y. And my candidates are going to be -1, perhaps some others, and a 3. So the critical numbers. Veterans, can you guys describe what critical numbers are?
Critical numbers is when the derivative equals 0.
Yay, or?
There's a horizontal asymptote.
Yes, and that would be where the derivative, f prime equals 0, or where the derivative
Does not exist.
does not exist. DNE. Okay, so what I'm going to do is I'm going to find my first derivative here. I'm going to find f prime. And so f prime is equal to, and this is where, so like Aiden and Jack doing the power rule from back whenever that was for you. That's what we're going to do here because these are just power rule situations. So it's going to be f prime equals 2 minus 2x to the -1/3. Is that making sense? Okay. And we want to find out where f prime either does not exist or is 0. We've got to consider both situations. So I don't know. Let's do this. Does this f prime ever have an x value where f prime doesn't exist? I'll phrase it a different way. If x equals blank, f prime dne. Is there a situation like that? What do you think, Jack?
Well, wait a second. Write it out. 2 minus 2 of x. Wait. Yeah. There is definitely at 0.
When x equals 0, yeah, how do you know that f prime doesn't exist when x equals 0?
Because you can't take 0 to the negative power.
Yeah, doesn't that make it a denominator?
Yeah.
Yeah, so I would say one of my other candidates will be when x equals 0. That's going to be when f prime doesn't exist. But let's also consider where f prime equals 0, right? That's where we get all of our candidates. So I'm going to write out 2 minus 2x to the negative 1/3 equals 0. And we'll try to solve this. Any suggestions on how to solve this? Or you might be able to do it in your head. When x is, say it, Aiden, I can see you want to say it.
1.
1, right? 2 minus 2. If x is 1, wouldn't you just get 2 minus 2? Yeah, so actually that's your other candidate. Oops. Okay, so then we've got our list of candidates. These are the only 4 possibilities. Aiden or Jack, any thoughts on what I could do to determine where, what actually is the absolute max and min? I've got all my candidates. How do I decide between them?
You plug them into f of x and find the greatest and least ones.
Remember, we're looking for the highest y and the lowest y. Aren't the outputs that you would find by doing that just y values? So if I take those candidates and plug them back into f of x, I'm going to get an output of y, and then another output of y, and then I can just easily compare those to do so. So if I plug in a -1, what do we get? Veterans, you get this one yet?
-5.
I think it's -5. I agree. When you plug in a 0, what do you get?
0.
0. When you plug in a 1,
-1.
-1. And I think for this last one, we actually did need the calculator, right?
Yeah, it's the cube root of 243. It's 6 minus the cube root.
Right. 6 minus the cube root of 243. Believe you. Did you estimate it with a calculator, anybody? No? Go ahead and estimate it with a calculator. I know I put no calculator on there, but I just didn't want you to cheat and just graph it and be like, there's the answer. Yeah.
Would have been nice.
Yes, but it wouldn't have been a really good measurement of how much you know.
No. I know my calculator really well.
That's good. You want to be good at it. Yeah, you don't want to neglect the calculator. That's for sure. Anybody, Jack's working on it. You all do need your TI 84s or negative 0.24, he says. All right, so then we can easily call out the max and min, and we want to do that. We want to say, here's the max, here's the min. So we could say the max is what?
0.
The max is 0. I'm getting that from right here. And the min is, what is it?
-5.
-5. That's the lowest y value. So we're just looking for the high and the low. We found them. We want to call them out and say, I found the answers. There they are. That table is neat, but you want to actually say what the answers are to the question. Veterans, I know you're rusty, but sort of familiar? You did this a lot last year, right? You did this sort of thing over and over and over. So hopefully it's in there somewhere.
That was fine.
Okay. Any questions before we move on? Okay. Fair enough. Let's see here. Let's do our next one. This could be our last one for the day because I think we're done at 30, if I remember right. I want to talk about this one, and we'll just kind of see. We might go back to 2. So look at 3. This is, for the uninitiated, This is a classic type of AP question, right? It'll give you some concepts, some information, and then it'll say which of the following must be false, must be true, et cetera, you know, those kinds of scenarios. Very conceptual, right? So read it over. F of 3 is 2, F of 8 is negative 4, F prime of 4 and F prime of 6 are both 0. Which of the following must be true? Give you a second to think it over. This would be a good time to like peek at your neighbor's answer or talk to them. Say, what do you think?
Is it only one of the following that's true?
Yeah, only one. Yep, only one option is the correct.
What do you think?
So based on the problem we just did, where the absolute extreme occurred at the derivative equaling 0. There are two spots right there where the derivative equals 0. So I'm thinking that's where the max and min are. What we don't know is,
Which one it is.
yeah, we don't know if it's max or if it's min. And if they're the only one. So I think C is your right.
Oh, yeah.
Why not D?
Just because the C is true and that there are absolute extreme and that 4 and 6.
Why don't they let you,
Because that's where
like,
the
see what you did on how you,
By saying that they,
what you did on the test?
Wait, are there other people that got 5 last year?
Or ever? Your sister's up there.
Okay, I was gonna say. Are we on? We're up there. That's so exciting.
Starting here, this is a group of like the BC kids with the sub-scores and all of this. This is just from last year. Those two. Yeah. It was interesting, yeah. Like our our 5 rate was a little bit lower,
What if it was
but our average score was higher.
Oh, yeah, you told me.
So we had a much higher basement.
I was like, everyone got 4s or 5s.
Tons of 4s and 5s, couple 3s, and that was it.
No
So
2s? What was our 5 rate?
it was really good. It was like 60%
Oh, shoot.
instead of about 70.
Yeah.
But like I said, it was interesting. It was like a little lower ceiling, but a much higher basement.
Yeah.
So it was kind of cool. Yeah. Okay, so I often am a fan of like when you get these questions where you have like concepts and bits and pieces of information, I'm going to try to graph stuff and just see what happens. So I know that f of 3 is 2, so that would be, we'll just say like right about there. And I know that f of 8 is negative 4, so we're just going to say that that's like right about there. I know that 4 and 6 are also some pretty important points, so I'll just put 4 there and 6 right there. I know that f prime is 0 there, so that might be a relative min or max, maybe. But would you guys agree with me that that's more or less all that I know?
that's all you know.
So let's think this through here, what this could look like. Would you guys agree with me that this could look like that? It could. Or it could, I'm just basing this on the information at hand, it could look like this. You maybe thought of it like that. Maybe you drew something like that. That's perfectly reasonable. Yeah, so based on something like that, you know, the absolute max is 2. Haven't we proven that it doesn't have to be that? Doesn't the red graph disprove that? Okay, the absolute min is negative 4. I don't think we've disproven that, but I think we could. Check this out. That just disproved B. The absolute extrema occurred either 4 or 6. Well, I kind of disproved that with the purple graph, didn't I? So weirdly, you know the answer that's never the answer? It was the answer. None of the above. Now there's one really important thing here that was not mentioned that actually kind of has to be mentioned in order for really any of this to be valid, like A, B, or C to be true at all. Oh, the function has to be continuous. It's that extreme value theorem. If you watch the intro or you look through the intro material, in order to guarantee a min and a max, you got to have a continuous function. And it didn't even say that this was a continuous function. So for several reasons, I would say the answer has got to be D. Okay, so I know our time's up. Tomorrow when I see you, we'll go back and we'll try number 2. And then we'll be charging into the mean value theorem, which is 3.2. We are not going to waste any time. We are rolling.
I'm excited.
You will not be bored in this class
When's
ever.
our first website?
I can promise you that. Say again?
Yes,
When's
it
our
is.
first website due? And then you
20th.
go to the website.
I don't remember.
Mine says no, that might have been physics. But like, there's a bunch that
I
are
saw-
like,
Pretty
you have like all of them. in,
pretty
though,
soon.
right?
They're all in. Yeah, they should
I
be
was
all
just-
in.
There's like
Yeah,
there's
I
like
was like,
five of them due on September 4th.
Wait, do we turn in our summer?
Oh yeah, I do.